I believe that is.
Hit the space bar to advance your slides and the plus or minus.
I can say advance and you can do it for me. Is that okay? Anyway, the previous slide was, about, being cautious about looking at the sun. I mean, everybody knows about that. But one of the cautions that you really need to worry about is, your cameras. Okay, and sometimes you can place it onto your camera and you can destroy the chip that's there. So you need to choose the correct filters. And one time, I went to pick up a filter, for one of my cameras, and I took a look at it and I burnt holes in it. So anyway, so this is a map of the eclipses that I've been to. Okay. So what I want to do is, this all started, when my son wanted to see Halley's Comet, years ago. And so he saved up and bought himself the little Tasco Newtonian, and we tried to see Halley's Comet and it didn't work. But a friend of mine had a C8, Celestron, and we set it up and we got to see Halley's Comet. And my son said, "Oh, it looks like somebody took a Q-tip and just went that on the screen." So anyway, so after that, what we did was, another, experiment. I bought a 10-inch Meade telescope and we went to Mount Pinos in Los Angeles. And what we did was we imaged, took a look at Mars and looking for storms and stuff on Mars. Okay, and what we did was we, gave the information to NASA, and they used a Keck telescope to see where the storms were on Mars. And this was before they sent the first probes up there. Okay, so doing that, I was in an astronomy club in Santa Barbara, California, and let's go see the total eclipse in Hawaii, 92. So what did we do? We packed up and we went to Hawaii, and we went to Saddle Mountain on the Big Island, and the only people on the island that saw the eclipse was on the Keck. And anyway, so that was 92. So 10 years later, I had an opportunity.
You tell me whenever
not
you're.
quite there. I'm still stuck on this.
Okay.
One. I'm still stuck on this one. So 10 years later, I got this notice from Jay Pasakoff. Now, I don't know if people know Jay Pasakoff. I was in the airport, a day ago, and this woman was saying, "Oh, do you know Jay Pasakoff?" She went to school with Jay Pasakoff. Well, Jay was the head of the American Astronomical Society, solar, whatever that group is. And anyway, Jay and I had traveled for over 20 years. Okay, and our first eclipse was to, Australia's on here someplace. Was to Sedona. Okay, and what I got to do was to go to Sedona with Jay's expedition. And what we did was we worked with students, PhD students, okay, and they were doing their experiments and everything. And I don't know if it happens now, but Stephen, one of my friends, what he does is I think it's the SOHO, it does images of the sun, and it died. And one of the experiments, they got it going, but one of them didn't work. But what Stephen did was he went to the eclipses with us and he took the central picture for that. Okay, so after Sedona, what we did was we went to a place called China, up to China. And that was fantastic because, it was like today, similar, but just before the eclipse clouds broke open, and we had 7 minutes of totality. And what did I learn at that eclipse? Don't do a flip on your telescope in the middle of an observation. Because just before totality, they wanted to do a flip, and they couldn't get it back. But that's okay. Yeah. So, so that's one of the things. So other things that we've done, and I went with Jay with that one, and for that eclipse, we shipped a whole pallet full of equipment. Other cool things we've done is we went to a place called an annual eclipse at Reunion Island. One of the things we do is we try to have tourist things about, in addition to the eclipses. So on Reunion Island, we went marching on this volcano, and we get on the plane and we fly away, and we hear later, almost on the day after we left, the volcano erupted. Yep. Okay, so we're getting there. So we've been to places like been to Japan. We've been to, Ternate in Indonesia. And we've been all over the place. And one of the things that was cool was we went to a place called, up there on the top left, Svalbard. Now, if you've ever been to Svalbard, you know it's cold. Okay, like, minus 24 in the middle of the day. And that was when you find out that batteries don't last very long. But the best thing about a battery is you can take it out of your camera and you can put it under your armpits and you can warm it up and get it to work. Okay, so enough from me. And just a couple of months ago, we went to Kenyatta, and that's where we did the annual eclipse a couple of months ago. Okay, let's change. We're running. We have to make sure we did it. So, give some history about all the stuff that we've been talking about today. Is the Earth is not the center of the universe. Everybody thought it was, and mathematicians were mapping out how the planets were going, and they couldn't understand why. Okay, the planets would look like they go, and they reverse and go back the other way. So Copernicus, a mathematician, said, well, if we make the sun the center of the galaxy, of our universe, then it makes it all, makes it all understandable. Okay, and so after that, Galileo, he's heard about this Dutch people with their magnifying glasses on the seas, and he put the telescope and he took a look at the moons of Jupiter and published a paper. And his response, the response of the Catholic Church to that was, "You're under house arrest because you're all wrong." Okay. So that's the beginning of science. Next one, please. Okay, so years later, Huygens, he was researching light, and Newton said, "Well, light's particles." Well, couldn't understand all of that. But a little bit later, Thomas Young, he did what they call a double slit experiment. And what the double slit experiment did was, by varying these slits, he could get fringe patterns. Nobody's seen fringe patterns before, okay, which is the basis of all the stuff that's going on today. And anyway, he demonstrated that light is a wave phenomenon. Cool. So what they did was, by being able to determine the angular diameters of things, tried to use 1850 type of thing, the Great Paris telescope. He thought he could measure the angular diameters of some of the stars. Well, back in those days, they burned coal, and the skies were so terrible, there was no way he was ever going to see anything. But 100 years later, we were able to. Next, please. Okay, so solar eclipses. Yeah. Everybody knows it's when the moon passes between us and the sun. About every 18 months, we get a total eclipse. Okay, and eclipses depend on where you are in your orbit. Next, please. So the moon's orbit is actually very complex. Okay, and the orbit goes around the Earth 27.3 days. And what's happened is the very, very center of the Earth and the moon are not in the center. So the Earth's gravity has caused the moon's orbit to slow down to where it faces this and rotates all the time. Okay, and what happens is when the moon comes down close to the Earth, okay, it speeds up and zooms around the Earth, and then it goes away and it slows down. Hard to believe that something that big speeds up and slows down within the sun. And because the Earth and the moon's orbit are kind of tilted, okay, we don't get the total eclipses all the time. Okay, now keep in mind that the moon is actually receding from the Earth. Now we're in a lucky time when we can have eclipses, see eclipses. Okay, and soon the Earth and the moon will be so far apart that the moon will, will just block it. We won't get eclipses like we get today. Next, we can do this. Okay, so what do we expect today? My friend Zara behaved. He was in Mazatlan right now, in Mexico, and with Fred Espinick and some other people that I know. They're supposed to be looking at the eclipse also. Now, keep in mind that the shadow that's supposed to come across it in an hour or so it's only 25 miles wide, and it moves at 2,500 miles an hour. I mean, it goes really, really quick. Okay, so for us, we need to put filters on for the partial phases anytime the sun isn't blocked by the moon. Okay, and everybody can do that. Next thing, please. We're gonna get this. Okay, here's a picture from Xavier's webpage. And yeah, it's looking better, but it's not great. So anyway, so this is what the shadow is supposed to look like when it passes over. And next one. And this is the timings from Xavier's page. Okay. And next one. So first contact is supposed to be 12:23. If it does happen, it'll happen. So what does it say? This is basically, my computer's going to tell us when to take the filters off and when to put the filters back on and all of that type of stuff. And the totality is 3 minutes and 53.7 seconds. Next. Now, when the moon goes in front of the sun, if we were lucky, it turns into night. Okay, and what you see as the moon goes in front of the sun, the shadows become sharper because the sun is becoming less distributed, becoming more like a point source. So when you take a look at the ground, the shadows just kind of they become really, really sharp during totality. During totality, everything is dark. Okay, and everybody needs, if we actually do it, okay, you need to turn your flashes off. There's nothing worse than, flash goes off, the white light blinds you and everything, and you just, I can't see anything anymore. Okay. So anyway, so there are things around, it actually looks that way, except you get the 360 degrees, sunset. Next page. Okay, so what's interesting about totality? Okay. It's possibly the best time for studying the sun. Okay. And in my box, I have a spectrograph. Okay. And normally the sun's spectrum is the Fraunhofer series. And if anybody's ever seen it, you can, I'll show a picture of it. But there's, thousands of wavelengths. Okay. But during totality, the sun's spectrum from the corona is only a couple of wavelengths. Okay, sorry, and we don't understand why the corona is actually, I think it's like 6,000 degrees hotter than the surface of the sun, and we would think that stellar, there'd be a thermal equilibrium would have occurred, but it hasn't occurred after all these years, and we don't understand that. Next, sorry. Now this is the spectrum of the sun right now. That's the Fraunhofer series. Okay, next one. Sorry. Okay, and this is the spectrum of the sun during the total eclipse, just before the total eclipse in Exmouth, Western Australia. I took this one, sorry, thank you. I took this one at Exmouth. Okay, and you can see an awful lot of stuff there. Now, next one. Now, this is what the sun's corona, the spectrum of the corona looks like. Okay, and when you come across here, it's like, that one looks like, that could be iron 10 or iron 14. And there's a couple of small ones in there, calcium, and a couple of wavelengths. Now, what I've done in the past is I've, used these spatial filters. Sorry about the cough. Other eclipses, I've used spatial filters. And what I've done is actually, very narrow, taken images of the sun during totality, at iron 10 and iron 14. Now, iron 14 at one time was called coronium. Okay, and that was about 125 years ago. And what they finally decided is that iron 14 is really the iron with the number of electrons, taken off, to have 14 left. And iron 10 is similar, it's just heated to a different temperature. Now, iron 10 is red and iron 14 is green. And if you take a look over here, you can actually see them. And that's H alpha. Next question, next one. So, That's what a partial eclipse is supposed to look like. And you can see sunspots and everything. And actually, there's not many sunspots for this eclipse. I was really hoping to see a lot of sunspots. Next. This was the annular eclipse that we went to, the entrance to the Monument Valley, and we took this. And what's really cool, you can't see it on this, but you can see what they call Bailey's Beads up there. You just see the start of it. And what Bailey's Beads is the sunlight shining through the mountains on the moon. Next one. Now, a friend of mine sent me this one, okay? And I've tried to do this, but what you have to do this is you take a fast exposure, a next longer exposure, and another one, and then you spend, like it says, 300 hours at the computer to make this, okay? And to actually get, this moon glow, it's incredible what you have to do that. Next month. Now, at Exmouth in Western Australia, I have pictures of these. And it's really way cool. But what I did to destroy that was I pushed the button on the camera and it zoomed out. It's just one photo. Next. So show me practice. Don't do flash. Remember, filters on, filters off. You do the glasses. And I got by in about 20 minutes. So how many questions do you have? That's good. I like it.
You're part of a group that does the work for scientific research for these, or how?
What I call it self-funded sciences.
Okay.
Yeah. What I did 25 years ago. Okay. I'll give you a hint. What I did 25 years ago, I designed electronics for, okay. And they ran out of funding because NASA was going to put an interferometer in space, and they have them out there now. And so anyway, so I became redundant, and I said, how long can I go without a job? I still don't have a job, but I get to travel the world. Okay? I get to do what I want to do, not what they tell me to do. But I designed things like, do you know what an avalanche photodiode is?
Yeah.
Okay. I designed the avalanche photodiode interface for the interferometer in Geiger mode so that they could capture the photons.
Oh, that's interesting. Yeah.
We did that. I did that. Okay. Now I brought with me from Australia an Age Alpha telescope, which I was hoping to show all the surface of the sun. It's sitting in the car right now. Yeah, I've got my high resolution spectrograph sitting in the car right now. Okay.
We have a few things sitting in the car.
So of all these eclipses that you've been to, obviously you've had to have some little positive, right? So they weren't all clear skies, right?
No,
You've always had clear skies, though?
no, because this is a radio astronomy stuff. Jay Pasikoff and I were supposed to, my partner Helen and Naomi, we were supposed to go to Helsinki, Finland for a partial eclipse. I mean, we get on the plane and we just fly. We just go. And anyway, just before we get on the plane, Jay cancels out. Okay, but Jay was dying of cancer. I knew it was coming, but I didn't know when. He canceled. But anyway, Helen and I got on the plane. We went to Helsinki, and we had made arrangements to go to the Finland National Radio Telescope. And this is nothing in comparison to what the clouds were in Finland. But they used the radio telescope and I pointed at the sun, and we saw the partial eclipse on a radio telescope. Not the pictures that I showed you, but similar to the ones that you've seen. That was really cool. So what did Dad do with that? I built a radio telescope in my backyard and I joined SARA. Okay. And I actually captured some data.
Jay Anderson.
Oh, Jay. tell you a story.
The premier forecaster.
Well, I'll tell you a story about Jay Anderson. We went to India for a conference. And we went up in the Himalayas. We didn't go to the Himalayan mountains, but we went up into the mountains in India. And I have a picture of Jay sitting in this, like he's on a toilet. That's okay. I shouldn't tell stories like that. Cool.
So important fact though, if we're so cloudy, it's still gonna get dark.
It'll still
Right,
get
so-
dark.
So that part will be the same, we just won't get.
Yeah.
We went 2017, we saw the eclipse, and it was, we're up in Idaho, it was beautiful.
To 2017, I went, to, inland in Oregon rather than the
Yeah.
coast, trying to avoid the marine layer. This is the marine layer that's been sucked in, from the Gulf. Right. But I keep looking and there's a water tower over there and it keeps getting a little bit brighter.
I've seen some shadows from people walking around, so it pokes out every once in a while. We might get lucky, even if there's some clouds, you might, if it's a little cloud cover, you still probably gonna be able to see the moon occulting the sun.
You'll see the
You just
shadow.
won't see,
You won't see the distance.
you won't see really distinctly, but you'll see a little bit of it.
And there is like a 15-degree temperature delta during the eclipse, and that can cause updraft and things that might open the cloud.
Thermal.
cover.
Keep our fingers crossed. I mean, one time, Jay and I, we went to Tokyo for an eclipse, and, the clouds opened up at the right moment, and we saw it. And that was, we got to stay at the, Japanese, national, radio solar telescope. That's cool stuff.
I think he knows all these people, but he's going to 30 or 40 eclipse, and he's seen them all standing around when he goes there. Ideal places.
Right.